Hello, everyone, and welcome to the TDWI webinar program. I'm Brenda Woodbridge, and I'll be your moderator. For today's program, we're going to talk about best practices to modernize the data layer in financial services. Our sponsor today is Redis. For our presentations today, we'll first hear from David Lotion with Knowledge Integrity. After David speaks, we have a presentation from Henry Tam with Redis. But before I turn the time over to our speakers, I'd like to go over a few basics. Today's webinar will be about an hour long. At the end of the presentation, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, click on the Help area located below the slide window and you'll receive assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. And finally, if you'd like a copy of today's presentation, use the Click Here for a PDF line there on the left middle of your console. In addition, we are recording today's event and we'll be emailing you a link to an archived version so you can view the presentation again later if you'd like, or feel free to share it with a colleague. So again, today we're going to talk about best practices to modernize the data layer in financial services. Our first speaker today is David Lotion. David is the president of Knowledge Integrity, a consulting company focusing on information management solutions for information quality, business intelligence, and metadata management. David is a recognized expert in information management and writes and speaks on the topic frequently, including at TDWI conferences and events. David is also an affiliate analyst with TDWI and the program director for the Master of Information Management program at the University of Maryland. Welcome, David, and I'll turn things over to you now.
Thank you, Brenda. I appreciate that. Let me see if I can turn my light on here and make it a little brighter. I thank you to TDWI for giving me the opportunity to chat on this topic today, and also thanks to Redis. We continue to have some good conversations with those folks, and particularly about the topic that we're going to talk about today. And we're going to, a little bit of an agenda here. We're going to look at some of the challenges that are facing the financial services industry and how legacy technology dependencies face challenges in maintaining competitiveness as the industry changes. We'll talk about how operational risks can be addressed by adopting a strategy for modernizing your data layer, and we'll talk about best practices for modernizing that data layer. So let's dive in there. The financial services industry has been around for a long time, and it is actually one of those industries where there's been very, very effective use of technology over the time. And in fact, maybe to some extent that might be a drawback these days, particularly because the systems have been engineered so well that organizations have been relying on them for decades in some cases. And yet the technology ecosystem for financial services businesses has changed dramatically in lockstep with evolving smart devices. So if you think about this, the way the financial services industry would be considered, I would say 30, 40, 50 years ago, you have your bank and you have a line of people who are trying to get into that bank. It's a physical location, brick and mortar, or in this case, it looks like it's stone, not necessarily bricks, but you've got a bunch of people, and what they do is they hold on to their transactions that they need to execute, and they bring them all together to the bank where they wait in line to talk to another person who manually does the logging of those transactions, and then those transactions are propagated later to some back-end system that then executes those in batch, and the system proceeds. But you end up with these artificially introduced dependencies to the technology that make one think that, yes, the actual execution of the transaction has to take place overnight, or has to take place, and in fact it's coordinated even in the industry itself, where they have mandated time frames for when certain transactions need to complete their execution. However, that's no longer the way it is today. If you look at a general population, they don't wait in line to get into to talk to a teller at a bank. Almost everybody is doing their transactions through a smart device, and so the transaction processing cadence has significantly changed from periodic batch to to real time when possible. So all these individuals who are looking at their smartphones, they're able to communicate with their banks, they're able to communicate with vendors, they're able to communicate with third parties, they're able to execute communications with any of these organizations, and these organizations themselves are interacting amongst themselves. So you've got different financial institutions that are providing different types of services so that an individual can go to a retail organization's website, they can do some kind of transaction through the internet. That becomes the point of sale, as a virtual point of sale. That point of sale execution may go through a third party that then coordinates with among all the different banking institutions, credit card services, or if you're going to directly to do like debiting from an account, they'll debit it from an account. You've got all this done, and it can be done all, number one, in real time. Number two, what you would call a straight through process. So in fact, it's no longer you log the transaction and then 24 hours later it will have magically executed, but rather it all takes place in real time. Now, what this means is that you've got more opportunities for coordinating activities across these different organizations. And in particular, you get the opportunities for cross-service or cross-product promotions, especially when you're dealing with a financial institution that has grown through acquisition to include multiple lines of business that go beyond just personal banking or business banking or credit cards. But you've got a whole range of different products and services, including mortgages and automobile loans and other types of financial products, but also in coordination with some of these retailers where you've got opportunities to do cross-organization promotions because you're dealing with all those different trading partners and information exchange partners all in real time. So the issue here that we find is that customers who have grown up looking at their phone instead of going to a location have grown accustomed to a certain level or expectation in their customer experience, and have little patience for when that customer experience is not consistent with what they believe to be true. So if you were a customer and you materialize in 2022 after having lived in 1950, and your experience is in batch processing after standing in line in the bank, you would be surprised to find that when you execute a transaction, there's some integrated analytical model that will do some kind of personalization and make you an offer to get a lower credit rate on one of your credit cards because it sees that the analytical model has determined that you are a better credit risk, and therefore it can reduce that cost, or whether it can offer a different type of insurance with lower premiums, or et cetera. If you were going the other way around and you were time blasted from 2022 back 20 or 30 or 40 or 50 years, you would be stunned and unaccepting of the fact that you would have that the financial institution does not really have any kind of visibility into an accurate, consistent, and up-to-date and fresh profile. So there are a lot of other business changes that are motivating the need to modernize that environment. So we started out by talking about the omni-channel customer experience, and that's really saying that customers are interacting not just through a single physical door of a physical location, but rather they're going to the location, they are making telephone calls, they are chatting through web chats, they are sending emails, they are doing texting, and interacting through a wide number of different channels. And there's an expectation that the perception that is being provided, or the personalization, is consistent with all the data, accurate data that's coming from all those different channels. So if you've communicated through one channel and then you show up to the location expecting to pick up your order and they have no idea who you are, you would not be very happy. So in terms of, in general, omni-channel customer experience, there's a need for a rapid integration of up-to-date and fresh data. Secondarily, there's, as I was referring to in that prior slide, you've got an expanded partner network or channel network where your organization is communicating with a lot of other organizations or third parties that are facilitating communication among those different organizations. So, for example, you may have a third-party payment processor that is coordinating funds exchanges between a whole range of financial institutions. And so your organization or your infrastructure needs to be able to support interacting with those different partners through the different channels in that expanded network. At the same time, legacy, I guess you would call them heritage, financial institutions are facing today competitive threats from digital-only or online-only fintech disruptors, different types of businesses that are emerging to fill gaps that existed as the technology has evolved, and the stodginess of legacy implementations and its inflexibility creates a challenge to be able to compete with processes and services that these fintech organizations and neobanks, et cetera, are able to provide. So that also is motivating modernization. Fraud has always been an issue, but it becomes much more critical when you are trying to transition from being an organization that does fraud detection and determining that fraud occurred 2 days ago, as opposed to correctly and accurately identifying and preventing fraud from taking place in real time. And so organizations differ in their capabilities of doing this. You don't want to be too zealous in claiming that some transaction is fraudulent, because you don't want, again, to impact the customer experience, because if the customer is continually bombarded with a suggestion that some transaction that they did was fraudulent when in fact it was not, that would raise suspicions about the organization's capabilities and being able to differentiate between a valid transaction and one that is not. However, if a fraudulent transaction does sneak through, that creates a risk to the organization, but it also, again, lowers the customer's perception of the viability of the organization to be able to accurately identify fraud in real time. And so fraud prevention is, and doing fraud prevention in an accurate and real-time manner is something that's motivating a need for modernizing the way you manage your information. Of course, compliance has always been an issue, regulatory compliance. And there's been a number of different existing rules, regulations, laws, et cetera, know your customer, anti-money laundering. These things have been around for a long time, but there's an increasing diligence on behalf of many geopolitical jurisdictions to mandate protection of personal data. But even so, those definitions of personal data differ from jurisdiction to jurisdiction. What's covered, what the objectives are, what the obligations are, becomes very complicated. You need to be able to have an environment that can handle all of the compliance directives. So that is motivating modernization. We've also got an opportunity as certain political entities and countries and organizations are creating opportunities for sharing information across different boundaries. For example, the open banking regulations in the European Union create both a challenge as well as a set of opportunities for being able to effectively share information among different organizations. But then again, motivates modernization, maintaining the level of performance for your systems. If you defined service levels that need to be maintained, and if you look at all these other issues that we've already talked about, that creates an increased performance demand, because there's more computation that needs to be done in order to support all these different activities. You need to still maintain the level of performance. And then finally, organizational resistance to change. The motivation to modernize also talks about migrating from legacy systems where there's been some aggressive turf management and control to more open environments where such as moving to the cloud or moving to a hybrid cloud environment, where the technology is different, where the processes are different, and that creates some level of resistance within the organization to transitioning from legacy technologies to modern technology. So we do have a lot of challenges. So let's take a break here and ask a poll question. What are your current data challenges that are slowing down modernization? And we're inviting everybody to select any of these options that might apply. Number one, slow applications. Number two would be maintenance or legacy databases. Number three would be data silos. Number four would be monolithic applications. Number five would be the lack of skills and technology to keep pace. And then finally, we've got a sixth option, which is other. And you're invited to use the Q&A panel to be able to enter some additional information that you'd like to be able to share. Also, at this time, I'll give you the opportunity to remember that if you have questions as we go along, you're welcome to enter those through the Q&A panel as well. So let's give it another 10 seconds or so, and we will transition to look at what some of the results are. Let's take a look at that. Looks like everybody, well, almost everybody's reporting that data silos are slowing down modernization, and that's not a surprise. And Henry, I'm sure we're going to get an opportunity to chat about this. But also, one of the things that we're seeing here is, mainframe or legacy systems, legacy databases, as well as the lack of skills and technology to keep pace. That is actually consistent with what we're seeing in some of these motivations to modernize, which has to do with resistance to change or legacy systems or the need for performance, et cetera. So lack of skills and technology, that is something that creates some level of concern. Henry, I'm sure we're going to get an opportunity to chat about that as well. But let's go forward. There are legacy technology issues that inhibit innovation, particularly around data accessibility and accessing data across different systems. And what we're starting to recognize when you are building your system in a legacy environment on premises, you do have some degree of control over the source systems, but we're tied or we're bound by the traditional architecture. And so, yes, we can get access to the data, but we do it and we engineer it in a way where we're extracting data from the sources and pulling it into a consolidation system like a data warehouse. But we're not expecting some degree of real-time accessibility, because we have to do all this intermediate processing and integration to be able to have access to that data in that analytical environment. However, to support personalization and recommendations and real-time customer experience, we need to be able to get access to that data. And so getting access to data across different systems in real time, in a reasonable amount of time without having to wait for the data to arrive. And that becomes much more complicated when we are looking at hybrid environments that involve moving data from one location to another location. So data latency is a technology issue that inhibits innovation. And what we're going to do is we're going to see how using a data layer, a modernized data layer, addresses some of these things. Number three is continuing to meet those performance expectations. Number four is the inability to integrate compliance into the data pipelines, and that also becomes a challenge, because one of the things you're trying to do is ensure that you are effective not only in complying with mandated regulations, but that you can do that in a way that is auditable and is rewindable, so you can demonstrate that your process itself have the right configurations to be able to identify a non-compliant transaction when it happens, as opposed to figuring it out a month later. And then finally, and this goes back to our poll results, different architectures require new skills. And there's some concern that if you, number one, if you want to migrate to an environment that is built on a different architecture, that you will need to get a skills replacement within your organization. And also you have to facilitate education and training to the individuals that are currently in your organization so that they can acquire the skills that are necessary to be able to support that new technology or that innovative technology. So let's say we want to be able to do this. We have to start at the beginning, and we have to look at some of the best practices to be able to get to the point where we can feel comfortable in doing that data layer modernization. So the first item I would say is identifying data accessibility gaps. So here's an example in this image. There's a woman who's dealing with one of her smart device apps that is communicating with her financial institution. In fact, that financial institution has a lot of data, and that data may be information that's coming and going back and forth with a sales organization or retail organization, or there's email transactions or point of sale data that's coming from the retail sites, or there's chats or texts, or there's credit card transactions that are being shared from the credit card processor associated with the retail organizations. And so customer data is being created all over the place. It's created at the point of sale. It's created through the texting and chatting. It's created through the process of executing the credit card transaction, any kind of e-commerce interaction that an individual has with a retail organization. All of that creates customer data. And to be able to have a consistent, accurate, and up-to-date view, the financial institution has to be able to quickly access and integrate data from across these different sources in real time. And again, if you recall, one of our issues the legacy technology issues is cross-system data latency. So we can't do things in real time if it takes more than real time to be able to get access to that data. So what the best practice number one is, look at your enterprise and look at how information is being shared and identify where data access gaps exist, so you can start looking for ways to alleviate the potential issues, either data consistency or data latency or data quality, those types of things. Number two is look to ensure a consistent omni-channel customer experience. So organizations, particularly in integrated environments or integrated business environments like financial institutions, they want to treat the customer as the customer of all the different lines of business and products and services. And therefore, you want to be able to have four fundamental expectations or support four fundamental expectations that are associated with that omni-channel customer experience. Number one, that the information is accurate and it's up to date. Number two, that your organization can enable a fast response time to the customer, that the customer is not sitting and waiting a minute for a request to be supported. Number three is accessibility to the full array of products and services. And if you look at some of the some more sophisticated apps for financial institutions, it provides visibility into all of the different products and services that are being provided, not just maybe personal banking, as opposed to having a separate portal for insurance or a separate portal for your mortgage. And then number four, that offerings are appropriately personalized, meaning that when an offer or a product or a bundle is being presented to the customer, that it is consistent with what the customer believes is something that the institution is capable of providing, and not something that is beyond their expectations, or not a product or a bundle or service that they've already purchased. And I'll refer to this comment below the image here. Supporting a real-time, consistent omni-channel experience implies that no matter which interaction scenario, the financial institution has rapid access to a materialized view of the customer's data pulled from a variety of sources and integrated from across different areas of the business. And that is the objective of maintaining a consistent omni-channel customer experience. So that is best practice number two. Number three, maintaining accessibility and interoperability with different information models that support real-time processes. So analytics-driven business processes share two key characteristics. Number one, they depend on rapid access to semantically harmonized information models. And number two, they're disjoint from back-end processing. Now, in the traditional data warehouse architecture, the system is engineered to address that second point, and is not necessarily capable of providing that first one directly. So it does it through smoke and mirrors by integrating the data through a staging process, by pulling the data out and being able to put it into that rapidly accessible analytical platform. Now, the problem there is that it's not real time. And so, if we want to look at some real-time processes like personalized offers or appropriately targeted advertising or bundling of products or limited time promotions that are in reaction to some sequence of transactions that the customer did, or cross-corporate promotions that are being done through some kind of arrangement with a trading partner, or the ones that we mentioned before, fraud prevention and compliance. Those are all examples of real-time processes that depend on rapid access to data pulled from these different original sources. And so when I talk about semantically harmonized models, what I mean is that you may have different systems that are supporting each one of the lines of business, and one is using a traditional relational database management system, and another one is using a NoSQL database, and another one is relying on a new application that's built on the cloud and uses data in a data lake. Another one is a system that's using data that's in a data warehouse that was built for the cloud. And so you've got these different underlying information models, but when you are trying to provide support for these embedded analytical processes, you want to have what I'm calling semantic harmonization, which says that if I'm pulling data from a relational database and I'm pulling data from a NoSQL database, as far as my analytical system is concerned, it's got to look the same. It's got to be available the same way. And so semantic harmonization has to be actualized with the kinds of optimizations of providing a real-time accessibility to ensure that real-time response. And this is where we start thinking about how you can leverage a modern data layer to reduce the overall complexity that provides a consistent and up-to-date representation of the data representing that customer. So that's the next best practice. The one that comes after that is understanding the architectural difference in development and how we've transitioned from developing monolithic, tightly coupled systems that are based on ensuring that all the operation and all the data work in lockstep together, and that when you do an update to that environment, you're adding functionality, you have to update the entire environment. And that's the way system application has been for a long time. The problem is that maintaining that monolithic, tightly coupled system increases a level of complexity when you keep incrementally adding functionality. So each time you add a new feature or you make a modification because of some change in the business environment, or you fix a bug, or you do an upgrade, whenever you do that, it requires a full system update, and that creates risks. And one of the things that financial institutions try to avoid are systemic risks like this. And so one of the recommendations that we're providing is take a microservices approach, which is, instead of looking at a monolithic environment, break down those capabilities into services or microservices that can be developed and implemented and deployed independently. It allows you to decouple functionality that is not necessarily needs to be tightly coupled. But it also simplifies the development and the deployment of those capabilities, because when you create a new feature, that new feature may not impact any of the other existing features at all. So why would you have to bring down the entire system to be able to add one feature when you can use a microservices approach where you're just adding in a new microservice and allowing the environment to make use of that service when it needs to. And by doing so, it enables modularization. It makes it easy to modularize your system. And in fact, if you use the right kind of data layer and infrastructure, you can migrate that entire capability across multiple deployment platforms without having to recode your application to address an underlying technical infrastructure dependency. And by doing so, this overall reduces risk. And that is a beneficial thing for organizations in the financial industry. So employ a modern data layer with microservices to build more sophisticated business function capabilities. And last, I think, one of the next ones is embracing a data platform for low latency access. And one of the ways of doing this is looking at an in-memory data store. and using an in-memory data organization that allows you to do both transaction processing and analytical processing on that same data at the same time. So robust in-memory architectures support simultaneous transactional, operational, and analytical processing, but it also provides you with scalable performance and persistence of that information, and you get all the benefits of a resilient system like high availability, but at the same time you get an adaptable layers of your memory hierarchy and flexibility in the way your platform is configured, so you can do things like on-demand elasticity and automated scaling and contracting to meet your performance needs. And if we think back to this question about developing microservices, that allows you to actually build replicable and containerized capabilities that can be deployed with little change across multiple cloud service providers. And so we can create this data platform or data layer that allows you to do interactions through that layer, caching and optimization and data access to those environments that simplify and speed response time and reduce data latency. And so once we have some of those things in place, you can operationalize that data layer with microservices, and you can provide rapid accessibility to those systems. So if you see this image, it's basically the same image I had before, except that by introducing these microservices into the environment, it supports multiple business processes and workflows and allows you to do integrated monitoring and compliance and fraud prevention, et cetera, all within the actual business process itself as it's deployed within that platform. So to summarize, changes in the financial services industry are creating new opportunities and are driving modernization. Reliance on legacy systems is going to diminish the ability of an organization to compete in a rapidly changing business environment. Best practices for data architecture modernization depend on adopting an operational data layer. And so we're recommending that you employ technologies that are engineered to address those needs, using a data layer, addressing the needs of the financial services industry. And with that, I am going to, again, thank TDWI and thank Redis for sponsoring this. And I'm going to hand it back to Brenda. Thank you.
Great. Thank you very much, David. And as David said earlier, we will be doing a question and answer session at the end of today's program. So if you have any questions, go ahead and get those entered now. And it is my pleasure to now introduce our next speaker, Henry Tam with Redis. Henry is the Senior Solutions Marketing Manager at Redis, where he drives the vertical industry solutions, go-to-market strategy, and messaging. He has over 20 years in the IT industry with broad technical and business experience in developing, launching, and managing software solutions that meet the digital transformation needs of data-driven industries, including financial services, retail, and healthcare. Welcome, Henry.
Thank you. So I actually want to start with a second poll. So the question is, what are the different specific modernization projects that you have actually started or maybe you've even completed? So you have zero back office. That's basically automating some of your back office processes. Obviously, a typical modernization project is improving the customer experience, right? It could be the mobile app, migrating apps to microservices that David was talking about, and then real-time analytics and monitoring, maybe using some sort of AI or machine learning model. And then the fifth option is this operational data layer, right? Using some modern data stacks like a NoSQL database. And then, of course, the last option is other. And again, if you want to use your Q&A panel to enter some other choices that you've done, we're just really interested to seeing specifically what are some of the things that you're doing to modernize both your application and your infrastructure. So let me give you guys, let's say, another 10 seconds or so, 10, 15 seconds to answer that. And then we will see the results. All right, so let's take a look at the results. Okay, so looks like a split between customer experience and real-time analytics. Again, no surprise based on what David was talking about earlier, and even for us at Redis, what our customers are doing. And then the second one after that, and I guess a little bit tied, is using NoSQL and migrating apps to microservices. So again, this is, again, in line with our expectations. And then we had some others. So I'm going to quickly take a look at other in the Q&A and see what those answers were, if I can figure out how to do that. So one said, transitioning of data platforms to Azure. So basically moving to the cloud. I should have had that as one of my options, because obviously moving to the cloud is clearly one of the more modernization trends. All right, thank you very much for all of those that answered. This is definitely confirming and insightful. So before I start on my presentation of how Redis plays a part in this modernization journey, I want to talk a little bit about age of real time. You heard David talk a lot about needing real-time data, accessibility, and I think we kind of all have felt or know that COVID obviously has driven an exponential growth in online services. We've heard from some customers that their digital transformation roadmap was accelerated from, they had like a 5 to 10 year plan, and basically they had to accelerate to a 1 or 2 year plan to keep up with this changing use of online, whether it's from customers or remote employees. But there's two other aspects of real-time I want to just cover briefly, and that is the whole notion of scaling and latency, right? So as the increased use of online services happen, clearly, you have to be able to scale to meet these kind of additional loads. And then there are certain industries, retail is a classic example where you're going to have these peak, buying days, right? Amazon Prime, Black Friday, and you have to be able to scale, elastically to be able to handle those kind of peak loads. And then the third idea is around latency, right? In the area of real time, truly, if it wasn't before, having that instantaneous response, being able to provide accurate and up-to-date and timely information through your mobile app, through your browser, through whatever interactive channel that you're going through, it has to be instantaneous. So we all live in the age of real time. And I think for those of you in the financial services industry, this is obviously also affecting your modernization and digital transformation efforts as well. So let me just quickly introduce Redis. Redis, for those of you that don't know, is the world's leading in-memory database. We are primarily known as a caching layer, but it's the most loved, most used, and most launched database and caching solution in the world. And again, these are all based on surveys and studies by Stack Overflow, Sumo Logic, and then the stats about the most launched. You just have to look at how many container downloads we have from Docker Hub. Our main focus since day one for Redis has been around speed and meeting these real-time data needs. But the other key thing for Redis and why it's been adopted so widely is it's really simple to deploy and manage. So part of what I'm going to talk about today is Redis Enterprise. So Redis Enterprise is the same, is built on top of open source Redis. It's the commercial version, available through various subscription models that layers on top of the native data structures that Redis already supports, whether it's hashes, which is obviously the most common use case data structure that are used, sets, streams, lists, even geospatial data. So all these things are built into the Redis open source version, and Redis Enterprise layers on top of that additional data models, including JSON. So with our recent JSON 2.0 launch, we now support native JSON natively. Also includes having a in-memory search engine that can do searches and indexing extremely fast. Supporting graph for those use cases that wants to trace relationships among the various nodes. And then time series, Bloom filters for probabilistic detection of fraud, let's say. And then on top of that, we add in what we call enterprise features, right? These are the core features around scalability that David talked about earlier. High availability. Redis Enterprise enables 5 nines uptime SLA. And then we support something that's really critical and in use by our customers, which is active geo distribution. So all these things are the enterprise layer that goes on top of the Redis open source. So why is Redis Enterprise the perfect, ideal real-time modern platform for these next generation of financial services applications? I'll kind of drill down to some of them that I just already mentioned. But number one, instant experiences, right? Being able to deliver sub-second responses because we're in memory to respond to those, for providing that seamless user experience. We provide the freedom and flexibility to build and scale modern applications, ones that are moving to microservices, right? So being able to support all the different data structures and data models all on one data platform really provides that unified layer for all those microservices. Thirdly, from a deployment choice perspective, Redis Enterprise, as well as Redis, is available on the cloud. It's available as a licensed software on-prem. And of course, you can obviously do a mix and match of both. And all of them using the underlying Redis Enterprise. So your data can be used across all these different environments. And then last, but probably the most important, for a lot of our customers in financial services, they're deploying Redis and using Redis for their mission critical applications. So we're essentially enterprise hardened to meet those mission critical needs. I mentioned the 5.9 availability, the active global distribution and replication. All of these things enables your applications that depend on the data in Redis to be globally available and resilient. So let me talk about some of the specific use cases that our customers are deploying Redis for. And again, this ties directly to some of the challenges and best practices that David mentioned earlier, right? So number one, I would say this is our top use case for a lot of our financial services customers. That is to help them improve the customer experience and really enable that always-on digital banking. Number two I will cover is around the notion of identity management and providing much more secure access to the data and the infrastructure resources. The third one I will cover is around risk management and compliance. And then the fourth one is, again, I think something that if you're not familiar with, I think you will be, is that we see a continuing trend around fraud and the ability to be able to detect it in real time as it happens versus after the fact is going to be critical to a lot of you out there that is on this webinar. So let me dive right in. Real-time customer experience. So for a number of our financial institutions, specifically for some of the leading banks in North America that are our customers, they use us to be able to provide that instant account information, balance information through the mobile app or through the browser if you're going through your desktop. And how it works, or the solution, is really that storing and as the customer is logging in and being authenticated through their mobile app, in the background, we're making asynchronous calls to the Redis, to the back-end databases where a lot of this information is stored. as you can imagine, David alluded to earlier about omni-channel, for this bank and for many of our customers, they have multiple lines of businesses that their customers are accessing, either products or services. So think about mortgages, think about your banking accounts, think about making the marketing promotion, think about investments, right? Your stocks, bonds, mutual funds, etc. And of course, credit card information. All of those are stored in disparate backend systems of records, right? And so how do we get and pull those out and present that information in a timely fashion? Well, this particular bank was able to store all that, pull all that information, store it in Redis, specifically Redis JSON, as a session record, session, all under the same GUI ID. And so by providing it in memory in Redis JSON, as the customer is getting authenticated, all this information is already getting assembled and built into the mobile app, right? It's pre-assembled, pre-formatted. And so by the time that the customer is fully authenticated and logged in, all that information is readily available. So it works like magic in the sense that it seems like we're providing them with the seamless and instant experience that they expect. So again, the solution is Redis as the front-end database stored in a JSON nested object, being able to present that account and balance information to the customers instantly. The second use case I find really, really interesting. A lot of institutions, a lot of companies are moving to a zero trust model. And in this particular case, this financial institution was developing their own kind of homegrown OAuth-based identity management solution. And they wanted to also implement a attribute-based access control model to get much more granular, provide much more granular access to not only the APIs, right, or data, but also the underlying resources and infrastructure behind those applications. And so the use case here is that there's a lot of requirements nowadays to do data sharing outside of the bank or financial institution, right? So think of a fintech app like Mint, right, where customers want to be able to upload some of their information to Mint to do their financial planning. Think about your tax preparation software. I know for myself, having just gone through the tax preparation process, you want to be able to export or link your transactions, let's say your stock sales or purchases, directly to your tax preparation software or platform, right? And so all these data sharing is basically inherently opening up the attack surface for those cyber criminals to be able to try to access your data. So this institution wanted to be the trusted identity provider. It wanted to be able to also provide much more granular access to what they had previously. And if you think about it, what does that mean? It means in a zero trust model, every request has to be allowed or denied. And then when you layer in the attribute-based model or this granular access, you're really talking about needing a solution that has the performance, the low latency, and the global availability to be able to provide that access. And a typical or traditional relational database, while it can certainly try to handle this task, it's going to be much more complicated and much more harder to provide that level of performance, especially if it's running on some sort of disk-based storage. So really the solution that we were able to provide is to store those attributes, the OAuth tokens, the user profiles, those general permissions, and basically host the attribute-based access control data to be able to provide that granular access control. And then taking advantage of the feature and the capability I talked about earlier, providing that active geo-replication so that no matter where that partner, that developer, or that client wants to access those APIs, that they can do so anywhere, anytime. So the third use case is really around what we call case management experience. So we know that we talked a lot about fraud and some of the other things, in other cases where this leading institution had to do a lot of manual investigation, right? And so they have these case investigators that determines things like whether this transaction really was fraud. Ideally, in the ideal world, you would be able to detect that automatically, but we know that there's still going to have to be some sort of manual investigation in some cases that has to happen. And so this particular institution was using Redis search to be able to not only index all that data, but to provide a really extremely fast and efficient search experience so that these investigators can look for patterns, can look for specific terms across different cases, right? Identify, again, help them to make that due diligence to identify whether this is in fact fraud or money laundering or any of those kind of criminal activities that are going on. And so Redis being the document store to host all this data. And again, this customer could have used some other search engine that was living on-prem in some sort of persistent storage. But then you also throw in the factor that would also have to be encrypted, which will also slow down the access. But because we're temporarily storing it, it's really the same as any kind of ephemeral data that is presented in the UI, right? And so again, we're able to provide that efficient search experience. And then the other area that we provide is that some of this data obviously is going to be updated. And so if you see in the middle of this diagram, there's this capability called Redis Connect. And that's really our change data capture framework that enables us to extract the data from some of these relational databases that house some of the data that these case investigators needed. And the last use case that I'll quickly go over, and then we'll move on to Q&A, is, again, real-time fraud detection. There's a number of areas that we can help in fraud detection. And supporting some of those other models that I mentioned earlier is a direct correlation to how we help financial service institutions and the payment processors and the merchants be able to detect fraud. Number one, we're able to leverage our low latency, high throughput data store capabilities to provide and keep digital identities up to date and real time, so that when you use us to do search and validation of the identity, we're able to provide the most updated information. Number two, the accuracy and speed of which we can be used as part of this, let's say, a transaction risk scoring engine to be able to detect and determine whether fraud has occurred. We have a AI module that can then be co-located with those features and data for doing the transaction scoring. And then, of course, we can use Redis as the online feature store for ML model serving because we're able to take the features and some of the transaction information in real time and be able to then serve that to that AI ML model. Again, taking advantage of both the historical data and the transaction data to determine fraud. And then lastly, we can do things like probabilistic filters, statistical analysis to our time series capabilities to do anomaly detection. So that's the third area where we provide real-time fraud detection. Lastly, and then we can move on to Q&A, is that I wanted to just highlight a actual customer, Simile, which is a PayPal service, and they're able to take advantage of Redis Enterprise to accelerate their fraud detection. They handle literally hundreds of millions, if not billions, of transactions, and we were able to improve lower their latency by 90%, reduce their system downtime by 20% through their use of Redis Enterprise. And so, again, just a quick summary: subsystem latency, giving you freedom and flexibility about multiple models, enterprise hardened, and and cloud ready, supporting multiple deployment options is some of the main things that our customers have used us for. So thank you, and let me turn it over to Brenda for Q&A.
Great. Thank you so much, Henry, for all the great information. Yes, let's go ahead and jump right into our audience Q&A. We'll start with this question for you, Henry. Someone is asking, what do you define as a real-time application? Most of our applications are not real-time, and how could Redis Enterprise play a part in that?
Right. So just I'll quickly explain. So in real time, we consider, if you think about a typical transaction from a client and app to the backend server, application servers, typically it's going to be around 100 milliseconds. And that's kind of the bare bones minimum, right? And so you have the network latency, the round trip time. But so if you think about it, if you have 100 seconds, 50 milliseconds going and 50 milliseconds for the response, real time means that you have to be able to access that data in probably less than a millisecond. So if you don't get a response in most typical e-commerce or applications within a second, that's considered friction that will hamper the customer experience. So being an in-memory database and caching solution, Redis is able to provide that sub-millisecond response. And that's what we really mean by a real-time experience. It has to be less than a second. And that's the part that Redis plays.
Great. Next question, Henry. Someone's asking or stating, I only use Redis for caching. Why would I use it as a database?
Good question. So again, I mentioned earlier, typically we've been used as a cache primarily to speed up access to, again, those customer experience and mobile apps. But really, I talked a lot about how Redis has grown, and especially what Redis Enterprise specifically brings, which is supporting things like JSON now. And so using us as a JSON doc store and leveraging that same speed and throughput of being in memory is one of the reasons why you would use us for a database. And Brenda, I know we're running out of time, so I wanted to address, there was one question around Redis being used to replace Redis Shift that I wanted to cover.
Oh, absolutely, yeah. Someone was asking, can Redis be used to replace Redshift, an OLAP database?
So we're not necessarily going to be able to replace those online application processing systems. So again, what we're saying is that we're not replacing your back-end systems of record. What we are saying is that you can use us as either a front-end database or a primary database where you take the needed data. So a classic example is that, some of those back-end databases store the last 50 years of information for their customers, right? For some use cases, let's say for analytics, you may only need to know the last 6 months of those transactions. So using Redis as the primary data store for those 6 months of transactions and being able to then leverage it for search and or leverage it for analytics, that is the type of use case that Redis is applicable to.
Great. Let's squeeze in this last question. Someone's asking, which is faster, Redis or DynamoDB?
Well, we believe Redis is faster. In some of our testing and performance testing that we've done, against disk-based databases, and even against, using something like AWS Elasticache, which is based on Redis, we are significantly faster. And I would be able to point you to, and I can respond after the webinar, and point you to some blogs that we've written that showcase and highlight the performance testing that we've done. And in transparency, we also tell you the method and methodology and what test tools we did to do the testing. And so that will give you a much better picture of the speed of Redis and our in-memory shared nothing architecture.
Great, thank you. So unfortunately, we have come to the end of our time. So let me just take a moment and thank our speakers today. We heard today, of course, from David Lotion with Knowledge Integrity and Henry Tam with Redis. Also, of course, a big thank you to Redis for sponsoring today's webinar. Please remember that we recorded today's event and we'll be emailing you a link to an archived version of the presentation. Feel free to share that with colleagues. Also, if you'd like a copy of today's slides, use the click here for a PDF line Finally, I want to remind you that TDWI offers a wealth of information, including the latest research, reports, and webinars about BI, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. There is also a companion checklist report that goes along with this webinar. You can find information about downloading that in the console or on our website. And with that, from all of us here today, let me say thank you very much for attending. This does conclude today's event.
Thank you, everyone.